Clouds vanish during a solar eclipse, and we finally know why. We have one coming over the United States on April 8th. When the moon passes in front of the sun in a solar eclipse, the jaw-dropping spectacle seems to change our world momentarily. However, the effects of our planet are far more profound than a few moments of darkness during the daylight hours, and one of the effects that might surprise you: clouds dissipate, and quickly, from the point at which just 15% of the sun is obscured by the moon. It's not all types of clouds, obviously, otherwise we'd never hear complaints about eclipses being spoiled by overcast weather. A team led by Victor Tries of the Royal Netherlands Meteorological Institute and Delft University of Technology has determined that, in particular, shallow cumulus clouds overland vamose with alacrity. The finding, Tries says, has implications for further attempts at climate engineering. If we eclipse the sun in the future with technological solutions, it may affect the clouds, he explains. Fewer clouds could partly oppose the intended effect of climate engineering because clouds reflect sunlight and thus actually help to cool down the Earth. From our vantage point here on Earth's surface, figuring out how clouds behave during an eclipse is not easy. But Tries says it's important. One of the solutions proposed to mitigate climate change is blocking some of the sun's rays from reaching Earth's lower atmosphere. While modeling suggests this could effectively lower temperatures, we don't know what other effects it might have, because cloud layers can be quite complex, and cloud configurations are constantly in motion. Counting clouds from Earth is not really a viable method of determining how solar dimming affects clouds. Another option is to study them from above using satellites, but previously these have not taken the moon's shadow during the eclipse into account in calculations of cloud top reflectivity, resulting in a bias in measurement of cloud cover and thickness. Tries and his colleagues figured out a way of correcting the lunar shadow by taking into account the proportion of the sun that's being obscured by any given time from each location on Earth's surface. By far, most of the solar eclipse consists of a partial eclipse, where there is still plenty of light outside, Tries says. This is partial eclipse satellites receive enough reflecting sunlight after correcting for the obscuration to reliably measure the clouds. The researchers applied their methods to data collected during 3 previous solar eclipses over the African continent between 2005 and 2016. To their surprise, cumulus clouds started disappearing in large numbers when just 15% of the sun was covered, and they disappeared until the eclipse had ended. Actually, why this was happening was unclear, so the team conducted simulations using cloud modeling software called DALES, D-A-L-E-S. These simulations showed that when the sunlight is blocked, the surface cools, which reduces the updrafts of warm air from the surface. Warm updrafts are instrumental in forming cumulus clouds. They carry water vapor that condenses into droplets as it rises into cooler altitudes, forming clouds. So when the ground cools and these updrafts cease, cumulus clouds cannot be sustained, recommencing only when the sun reemerges and starts warming the ground again. This effect occurs only over land, since the ocean does not cool quickly enough for the effect to kick in. Cumulus clouds are not rain clouds themselves, but they can transform into rain clouds. The team's finding suggests climate engineering that involves blocking sunlight could have a pretty detrimental effect on weather patterns. Since this is sort of the opposite of what scientists would want to happen, the phenomenon warrants further investigation, the researchers say. And the research was published in Communications, Earth and Environment, and this is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.